But we can get rid of the Pret, can't we? Or we can't. Come on.
I'm going to be drinking it throughout, though.
In defiance.
In defiance. You.
Screw you, world.
Yeah. Hello and welcome to the latest edition of the Author Hub C1D1 podcast. So, a lot of people are asking us for non-orthopedic content, Pete.
Yeah.
A lot of our fans. We're going to give our fans what they want. Does that sound slightly...
That sounds awful.
As
always, yeah.
Yeah, as always. But, you know, a lot of people who listen to this aren't medical. We've got some fascinating topics, and this is going to be really exciting. I'm really looking forward to this. Particularly, those people that know Pete will understand why this topic is just so relevant to Pete if they know that apocryphal story. Let's just leave it at that. Pete, what are we talking about today?
Today, it is a departure for us because we're normally all about bones, aren't we? It's all about the bones and the joints and stuff. Today, it's bugs. And we're covered in them. We're covered in them, inside and out. And it kind of turns out that's actually okay. Because we've evolved with these bugs and we've kind of grown up with them throughout our evolution into human beings, we've got this sort of symbiotic relationship. You give me something, I give you something, and we've learned to live together. And it turns out that actually this relationship we have with them has benefits across the board. Health, mental health, immune system, sex life, general happiness, resistance against disease, not to mention like your bowel habit and stuff, and, you know, have nicely formed stools, etc. So,
yeah. No one likes a pale stool.
Yeah, exactly.
Okay.
So, and that's completely exhausted my knowledge on the topic. So from then on...
You should write a book.
Yeah. That's literally what a 6-year-old would tell you.
Yeah.
They'd be right.
Bugs.
So we have this microbiological orchestra singing to us, and we hum back appreciatively to them when things are good, but when things are bad, when the conductor loses his score sheet and everything's out of tune and the violins aren't properly primed, it turns into a bit of a shit show. And that is why we've got James Kinross here, recent author of Dark Matter.
So those of you who are watching can see I'm holding a copy of Dark Matter. The first time we've actually had a book. James, how does it feel seeing it in the wild?
Do you know, it's mad. It
Is it?
totally does my head in every time I see it. I don't know if I'm allowed to say this, but had a sort of celebrity cook came into my clinic and he asked me to sign it today. And it was probably the best thing that has ever happened to me.
yeah,
Yeah, it made me feel really like
Fantastic.
that's it, I've achieved something.
Please don't sign this one. I want to sell it afterwards. Okay. Now listen, I don't want anyone to say that we don't take our research seriously. I bought the book. I even downloaded the audiobook. I've fallen asleep to James.
That's 10% of my sales.
Yeah.
I think I definitely owe you something for that.
Look, and the only reason, I just want to say, the only reason this book looks pristine is because I've treated it with love and respect, not because I haven't opened it at all.
You're a good
Honest.
man. You're a good man.
So listen, the bio is here.
Go on, read it.
Oh,
out.
God.
I didn't even have to
Really?
Google this one.
Okay,
I didn't even
go
go to Wikipedia. Dr. James Kinross is a senior lecturer. Hold on, you're not a senior lecturer.
I think I'm a reader.
You've been
now.
promoted. You're a
I'm
reader.
assistant professor now in New Money.
An associate professor.
Yeah, I think that's what they call me.
Yeah, a reader.
Yeah.
I'm a reader.
Good man.
Oh, God. You had to get that in, didn't
Pete,
you?
are you a reader?
What have you read?
What have you read, Pete?
Oh, what?
Yeah.
So, is a reader in colorectal surgery and consultant surgeon at Imperial College London.
Mm-hmm.
Although it says college, they assure me it's a university and not just a
One of the
secondary.
finest.
Yeah. He's also a visiting professor at the Royal College of Surgeons in Ireland, to be sure. He leads a research team defining how the microbiome causes cancer and other chronic diseases of the gut. James is also a huge fan of Taylor Swift and has seen her perform live over 100 times.
She's amazing, aren't you? We all.
Dark Matter is his first book. So welcome, James Kinross.
Thank you, chaps.
It's all one.
This is the orchestra. This is the
shit.
This wouldn't happen to Taylor Swift.
It wouldn't happen. She'd be better prepped.
Yeah.
Okay, enough.
Yeah, it's supposed to stop. So listen, Pete, I went to med school with James.
Mm-hmm.
He was a year above me. I haven't seen him over 20 years, and you literally have not aged a day.
Listen, don't you start. I'm very vulnerable to flashback. It's not true. I've lost hair. I'm grey.
But to be fair, you had an advantage because you were preternaturally grey in your 20s.
That's true.
At med school.
Yeah, I know.
So you haven't changed. And I imagine Pete's always looked like an adult fetus. So he hasn't changed much either.
Hard to imagine it any different.
No, but James has always been a gorgeous man. He's like the George Clooney of bowel movements.
Flashy will get you everywhere. I'll tell you that.
So the Taylor Swift thing, does that go back right to the start?
No, I made that up. It's not in the bio.
It's not.
I just made it up.
But you do like it, right?
She won't stop texting me. It's getting awkward. Have you heard that song, London Boy?
Yeah, London Boy. Is
Just
that
saying,
you?
just saying,
Yeah.
just
Could well be.
Hackney to Shoreditch.
Yeah, she's just...
I'm giving it away now, aren't I?
She's just, insufferable.
She's epic.
Yeah.
So, James, your lack of aging, is it because you've optimized your microbiome?
It is because my microbiome is robust.
Do you see what we did there?
Yeah, it's very
Quite
good.
slick, right?
Very good.
That was orchestral.
Very good. Yes. Very good.
Pete, why don't you kick us off?
What is it? Just tell us about this. We're covered in bugs, inside and out. But what bit of that is the microbiome?
Good question. So, a microbiome can be conceptualized as a collection of all microscopic life forms and all of the things they need to sustain themselves within a defined niche, right? So we have a gut microbiome, and we have a skin microbiome, and we have a lung microbiome. But within those anatomical organs, there are kind of microscopic niches that have their own microbiome. So within the gut, for example, you will find a different microbiome that might sit within the crypt next to a villi, for example.
So listen, you're talking to an orthopedic trauma surgeon here.
Yeah, so sorry.
What's he talking about?
Yeah.
What's he talking about?
Yeah.
So if you think about the microscopic architecture of the gut, you might know from GCSE biology that within the small bowel there are lots of little fronds, finger-like fronds that wave and billow and flow.
It's like seaweed.
Yeah, it's exactly like that. Yeah, and those things absorb nutrients and absorb food, and they've got their own little niches of microbes that adhere to them. So we have microbes, as you say, on us and in us. But
as in bugs.
As in bugs.
Yeah.
But there's two kind of important things. The first, and you kind of brought it up in the introduction, Pete. A microbiome has a profound symbiosis that has an evolutionary basis. So most organs in our body have a transitory relationship with a microbe at some point. Even what we think is very sterile compartments like the brain might come into contact with a bug, perhaps disastrously at some point. But a microbiome is different. It implies an important symbiosis that maintains and optimizes health. And that evolutionary timescale happens, of course, over many hundreds of thousands or millions of years, but it also happens and changes over the timescale of our lives. So we're not born with a microbiome, it's got to grow, and as we age, it changes, and therefore its health functions change. And the second thing to say is that you should not think that we know completely what is in a microbiome, because we do not. And that's why this book is called Dark Matter. So it's a bit like we discovered a brand new organ about 20 years ago, and we're still working out what it is and who's there. And the biggest sort of scientific projects have been mapping exercises, trying to work out, which type of bugs are there. And we don't know. And that's why it's called Dark Matter. So just to go into a teeny tiny bit of detail, and if I'm boring you just tell me and I'll stop. Right. So we know that bacteria probably. Yeah. Very good. Very good. So bacteria are probably one of the most dominant microscopic life forms that live there. But actually, those are the archaea, which are sort of ancient different kingdoms of microbes. There's parasites and yeasts and lots of other microscopic life forms, and the biggest actually might be viruses, right? So the virome that is there. And to give you a sense of scale, because it is kind of does my head in how big it is when you think about it, there's probably about 500 to 1,000 species of bacteria that are in your gut right now, Pete. But they're probably coding for anything between like 30 million to 100 million microbial genes. Bear in mind, there's only 25,000 genes that code all of your functions, right? So you're
probably less for me.
Yeah, you're dwarfed at a genomic level. You're dwarfed by your microbiome, right? And we haven't really mapped all of the species that live within us in terms of bacteria. Right? We don't really, we haven't got a complete definitive list. We keep discovering new species all of the time. There's about 150,000 species of phage. They don't exist in
phage is a virus.
Phage is a type of virus that affects a bacteria, right? Yeah. Got no idea who's there. They don't exist in our databases. We don't know what they're doing. We don't know they're interacting and shit.
Right, because we've never looked at them because they gobble up bacteria, or they use bacteria to do their multiplication for them.
It's bonkers. All bacterial life forms on the planet are turned over every 48 hours by phage. They're the most dominant parasitic cellular structures on the planet, and they are absolutely everywhere on everything that you touch and everything that you look at.
They are killer gorilla.
They're killer gorilla, and we don't really know how they influence our health at all.
Yeah.
And that's why this book is called Dark Matter, because when you think about the forces that govern the world around us, and you think about the universe, we know that 95% of matter out there isn't actually explained by the standard model of physics, right? It's this thing called dark matter. It explains why galaxies don't break apart and how the universe is bound together. It's the same with healthcare. We only think about the 3 to 5% of genes that we actually understand and can measure, and the majority of it is we don't know. It's genetic soup, and we'll just pretend it's not there.
Shit happens.
Yeah, well, literally my job, as it turns out. Yeah. So the microbiome is, we know a little bit of, we know quite a lot of what's there, but there's a big bit of what we don't know.
Right, and also it's the connectivity of it as well. So you can put a swab in, you can say, right, there's that bacteria, or these 10 bacteria sitting right there at this time. But how they connect, how they interact, and how they are different from the bacteria like a foot further down the colon, or even like 6 microns further up one of those bits of seaweed.
Exactly right. So microbes function in connected networks in living systems. So when I did my PhD like 4 million years ago, my PhD was in systems biology. So that means like how you try and get a really big picture of an organism or a cell or a structure, and try and work out by looking at the bigger picture what might be going underneath. And what that tells us is exactly that, is that all these microbes are connected. And that allows us to reconceptualize healthcare and what healthcare might be. So when we went to medical school, all those decades ago.
Glorious times.
Amazing, happy days.
Yeah.
We were taught in a really siloed way. You learn about orthopedics, and then you might learn about general surgery, you might learn about whatever. And you don't think that they might be connected in some way.
Yeah.
And similarly, we don't think that microbes might connect our health across different organs. So it turns out that the bugs in your gut play a really important role in your bone health. They play a really important part in your mental health. They play a really important part in your cardiovascular health. And these things are all intimately connected. And that's been probably one of the biggest surprises in the last 20 years of research.
Yeah.
So what happens when the microbiome goes wrong?
Before you answer that, can you say what's a microbiome functioning healthily, functioning well? What is it actually doing for us?
So that's a really hard question to answer, and I'll do my best to do it succinctly.
Hold on, isn't this what you do research in?
Yeah.
And you've written a book on it.
Well, I've written a book on it, and I'll try and ask. So you have to think about the microbiome as sort of existing in a quantum state, which means that it's never really still, it's constantly evolving. And that's because you need different things from it at different stages in your life.
Yeah.
So a healthy microbiome when you're born and you're a few days old is very different to a healthy microbiome when you're in your 80s and 90s and you're kind of declining, right? Yeah. So the answer to that question, first of all, is time dependent. The second reason why it's quite hard to answer is because you could think about it as who's there. So to have a healthy microbiome, you might think about it in terms of ecology. So you've got the right number of bugs and the right abundances and the right relative proportions of microbes, right? And we've got a whole ecological language to think about when you talk about that. And the third way you could think about it is in terms of function. So what are these things doing? Do they have a core set of functions that you've just got to have? And if you don't have them, you're not healthy. And that might be a better way of thinking about it. Yeah. So the way I think about it is that a healthy microbiome is one that is resilient. It's one that can adapt to change. It can take an antibiotic hit. It can take, a trip to the Far East and a dramatic change of diet, as I've just had to do, and it doesn't change. It stays quite stable.
Or Whitechapel.
Or Whitechapel. Excellent food in Whitechapel, right? And it will sustain and it will have a degree of plasticity. It'll adapt to kind of what it is that you need, and it will adapt with you as you grow. But that is a big problem in microbiome science. Like, I keep asking this question of microbiome scientists who are much cleverer than I am, and I say, what is a healthy microbiome? And we don't really know. And the problem with that is that it's very easy then to manipulate microbiome science to any particular goal you might have, because there's this word called dysbiosis. Have you heard of that word?
No.
Explain that.
It's my bugbear. So dysbiosis means that you've got an abnormal microbiome associated with a particular disease state.
Right.
So it implies that, let's look at people who's got osteoarthritis, for example. We'll sequence their microbes, and lo and behold, they're different to people that don't have osteoarthritis. Well, is that a cause or is it an effect? Yeah. Right. But people don't care about that. They will call it a dysbiosis. You've got a dysbiosis.
Yeah. But with a particular disease, would you expect to see a similar microbiome across everyone who's got it?
Well, no, you don't. And I think there's been a sort of shift in microbiome science from doing sort of big multi-omic analyses where you're trying to look at everything all of the time, all at once, to doing quite more focused mechanistic work to try and understand that. And we know that there are really specific bugs that do really specific functions that cause or drive disease. But I would flip that around. And the bigger question is there a specific microbiome that optimizes health and maintains health? That's a harder question to answer. Or are there core functions that you need to maintain and optimize health? Yeah, there are, and we're beginning to get a better idea of what those are.
Okay, now can I ask my question?
Yeah.
So, what happens when the microbiome goes wrong?
Okay, so again, it depends on when it goes wrong, right? And so
let's say you're in your 40s.
Okay.
30s or 40s.
So let's just say, for example, you're in your 40s, you're an orthopedic surgeon, and you know you
your
might
best
have,
days are behind you.
You're contemplating your career choices. So the answer is that when it goes wrong, it can be bad news, but the consequences of the microbiome going wrong may take time to manifest themselves, because the major insight that we've had is that the microbiome is a major driver in your risk of chronic disease. And the big insight is that it basically holds the strings to your immune system, right? Which is why it's becoming interesting in orthopedics, right? Because the immune system affects everything, very obviously, right? Yeah. So what we know is that when it goes wrong, it tends to go wrong slowly, and then that leads to this epidemic of immune-mediated chronic diseases that we see escalating across populations all over the world. At least that's one theory.
Yeah.
Right? It might be infinitely more important, and in fact it is in my belief system, that if it goes wrong in very early development, it's much, much more serious.
Yeah.
So if the maternal microbiome isn't programmed right, the gestating infant is going to be at a disadvantage. And if in early life the microbiome isn't seeded right and it doesn't grow right, the consequences for that might be lifelong.
Okay, that makes sense.
And that's a big concern.
Yeah.
And so
like a dysplastic hip.
Yeah.
Just like it.
Yeah.
And so, what can women do? Now, pregnant women must be thinking, right? What do I need to do to make sure that my microbiome's right, and B, that gets transferred to the newborn?
Yeah, good question. So the answer is of course we're all responsible for that. And I think you could take a philosophical approach to that question, or you could go into kind of real specifics, right? And just to take a philosophical approach firstly, because it's kind of easier to manage. The way that I think about that is that you have to think your relationship with microbes. So instead of thinking about them as all being harmful, and lots of women having pregnancy are screened for pathogens because pathogens cause harm, right?
Yeah.
But you've got to think, well, okay, maybe I need these bugs to maintain not just my health, but the health of my infant. And that means that you've got to feed them right, you've got to nurture them, and it means you can't destroy them, you've got to protect them. So what that means is that nutrition and diet is super important, right? And you've got to have, you've got to de-Westernize your diet as much as you can. We can get into the weeds of why that's kind of an important thing to do. It means you need to avoid things like unnecessary antibiotic use unless you really, really need it, or avoid taking medicines unless you really, really need it. It means that you need to ensure that you're vaccinated because that reduces your risk of antibiotic consumption. It means that you need to think quite carefully about how perhaps the choices that you're going to make about how you're going to have your baby and how you're going to feed your baby once your baby is born. These are really contentious, difficult things to talk about because, of course, women and new mums deserve choice and they are free to make that choice. And, of course, some women have to, have cesarean sections or cannot breastfeed. So I do not want to make anybody feel guilty that they can't do or it's not important. But we do know that if you do those things, the health benefits for mum and baby are significant.
Yeah.
What are some of the most common factors that can disrupt the microbiome?
Beer. Lots and lots of beer.
Pete's still hungover from last night.
Beer.
Yeah.
Well, so there's, again, like you could get into the weeds in this, but I'll give you like 5 really big ones.
Yeah,
the big ones are kind of over the last 70 or 80 years. So basically, since the 1940s, we've experienced this process of hyper-globalisation, right? And one theory is that this is causing this sort of dramatic change in life forms. And so the big one, obviously, is nutrition and diet. So you've got a globalised diet, and that has been a big player.
And by that, you're referring to the fact that wherever you go in the world, you've got a McDonald's, a Starbucks, what have you.
Absolutely. I was in Guangzhou the other week. There's a McDonald's There is indeed a Kentucky Fried Chicken.
Yeah.
It's all the same. We just eat crap, right? And it's homogenous, ultra processed food. It's been a disaster.
Why do bugs not like ultra processed foods? What's so bad about it?
So some of them really like it, and that's the problem. So you get these super blooms of some bugs that really just gorge in it,
This is so good.
morbidly obese bacteria chomping on it. But also what happens is that you lose that diversity, you lose that richness, and you lose the functions that you really need to maintain that homeostasis.
Right.
But and we can talk about that because we've done quite a lot of science swapping around diets of rural Africans and African American men, trying to see what happens, and the functional consequences on the microbiome of westernized diet are really dramatic and profound and quite frightening when you really look at the data. But I'm going to answer your question very quickly. So diet, number one. Number two, antibiotics. So what you have to think about is that we've systematically done our very best to destroy all antimicrobial life forms in about 70 years, right?
Yeah.
Now, the majority of those antibiotic consumptions are not in hospitals and not given by doctors. They've actually been in farming. So 80% of all antibiotic use at the moment in the world is in farming it used to be for antibiotic growth promotion, and now it's for animal husbandry, right?
And it gets into all our diets.
It's in our water, it's in our soil, it's absolutely everywhere. And that's been a huge, huge driver. And antibiotic consumption is growing, not going down. So between about 2000 and 2015, antibiotic prescribing went up by about 65%. We give about 38 billion daily doses of antibiotics. It's insane. Like everyone, it's just a wash in antibiotics. Most of that growth is coming in the developing world, in India and China. It's not here. The third is drug consumption, medicines. So we take about 4 trillion doses of medicine every year in the world, which means that every day somewhere in the world, half of the world's population is taking a medicine. And many of the medicines we take actually have antimicrobial properties. We just don't think about them in that way.
Well, there's always like 20 side effects. It can cause indigestion, constipation.
Yeah, exactly
vomiting.
right. And then there's exactly. So proton pump inhibitors is a really good example, right?
Yeah.
The fourth is going to be climate change. Right, so we are being urbanized. The planet is heating up, and because microbes literally and figuratively connect us to our environment, we are seeing a shift. Right, and the final is I call it conflict, but the reason I call it conflict is because conflict causes, amongst other things, mass global migration, right? And that's shifting it. So collectively, what you're seeing is not just a decay in the microbiome, but there's this theory of the disappearing microbiome promoted by a guy called Martin Blaser in New York. He's like one of my heroes. I'm a bit of a Blaser fanboy, but
have you met him?
Not met him actually, but he's a good man. Check out his book. He wrote a good book actually. But and his theory is, look, the microbiome's it's literally we're losing it, right? It's becoming extinct, and we're losing our internal biodiversity in the same way that we're losing the biodiversity of other planetary ecosystems that are important, and that these things are passed down from mother to baby. Right, and that's why the maternal microbiome is so important, and that we're losing it.
Okay, so generation after generation is getting it's not something that's happening over the course of like a year or two. It's happening
exactly right
as a thing over time where maternal microbiomes are degrading or become less diverse.
And we as a humanity are becoming less resilient to all kinds of inflammation.
So what I say is that we're living longer. I mean, we've literally never lived longer in the history of our planet. It's amazing. We've got more people over the age of 65 than we've got under the age of 5. But we're not living happier, right? So we're living with an increasing burden of chronic disease that doesn't kill us. It disables us and leaves us trapped in very expensive healthcare systems that are not equipped to deal with it, right?
Some people would call that inflammaging.
Inflammaging is a good word. It's a good word. It's a good word. Yeah, so inflammation is the natural consequence of losing that diversity. But the other thing is that it's not just that these bugs are extinct. You will know that bugs have these amazing abilities to share genes and to communicate and to develop resistance super quickly. So these bugs are mutating. They're doing their best to survive in an increasingly demanding and restrictive environment, just like we are. And they're not lying down and taking it, they're fighting, right? And the consequence of that is actually inflammation. So it's not just that they're being extinct and disappearing, it's that their functions and their relationship with us is changing.
And inflammation is the underlying cause of every chronic disease, mental and physical, right?
Yeah.
Essentially, right?
Yeah. I mean, it pretty much is. Like, it always comes back down to it, right?
Yeah.
And you know it is when an orthopod knows what a T cell is, right? Then you know, you're like, oh, shit. This is bad, right? So, it is. I firmly believe that. And that's why, that's why, like, the microbiome in early life is so important, because it primes the immune system.
Yeah.
And if you don't educate the immune system early in life, you've got real problems. And that's why half of Europe is going to have an allergy by 2025.
Yeah,
What the hell?
And it's interesting, amongst my kids and their peer groups, there's so much allergy, it's unreal. And there's a bunch of kids carrying EpiPens in a way we've never seen before.
Yeah, for sure, right? So there's an epidemic of allergy. My clinic is full of people with food intolerances and bloating and difficulty eating and swallowing. And it's endemic.
You should have a word with him, Pete, about your bowel.
Something to be embarrassed about.
Yeah.
It's okay. It's okay. We can have a chat.
Not just yet.
Yeah.
What about smoking? You didn't mention smoking.
Did you smoke when you were...
Never smoked.
Never smoked.
Actually, at med school, I'd have the odd cigar after we won the cup or something.
Yeah,
But that was it.
So I used to smoke. I don't
did
smoke
you?
anymore.
Yeah.
I stopped smoking.
I was like Will Smith. It was for the look. I don't like it.
Yeah, it's the single worst thing you can do for your health.
Yeah.
So smoking is a disaster for lots of different reasons. Interestingly, cigarettes have their own microbiome. In fact, did you know we owe all of virology to the tobacco industry?
I did not know that.
Seriously. So when the Dutch imported tobacco leaves from Central America, they had an epidemic of this disease that was killing all of their tobacco plants. They couldn't work out who it was. I can't remember the name of the Dutch scientist. It'll come back to me in a second. He was famously dour. It was about the 1630s. Anyway, he couldn't work out. He was sort of tasked to work out what it was, and he came up with this concept of a chamber filter, which filtered out these microscopic organisms, which turned out to be viruses, and worked out that actually it was an infectious disease. And lo and behold, all of modern virology was born. So without smoking, we wouldn't have virology. And each cigarette has its own microbiome because it's plant-based, and it's got its own plant-based organisms. In fact, you can sequence a cigarette and work out what brand.
And when you inhale it, that goes into your microbiome?
Well, no, it doesn't, because they get cooked. So smokers have different lung microbiomes. In fact, they have all of their microbiomes are different. They have different colonic microbiomes, different GI, different skin, different everything. Because of course, there are confounding factors like lifestyle factors. They might be more prone to eat, junk food or to drink alcohol, etc. So the microbiomes do change. But actually, when you go into animal models and you account for those things, even then, smoking changes your microbiome.
Does it kill off some bugs?
Yeah, it will do, and others will predominate as a result of it. And there's been some nice studies on this. And again, we see with smokers, when you look at smoking doesn't just cause lung cancer or damage to the lungs like chronic obstructive airways disease. It causes a whole host of inflammatory problems, right? So it's got, it increases your risk of bowel cancer, it increases your risk of bladder cancer, it increases your risk of inflammatory bowel disease. Or actually decreases
bad across the board, isn't it?
Bad across the board, right? And that's one hypothesis is that, of course, that it's having a systemic effect on inflammation, and the microbiome is a mediator of that effect of smoking. So smoking bad.
Gotcha.
Tell us a bit more about the effect on bones and joints, and also inflammatory bowel disease. So let's start with joints.
Obviously, start with joints.
Let's start with joints.
It's a natural lead-in from smoking, isn't it? So what I'd say is that there is now this appreciation that there is a gut-bone axis.
Right.
And again, the mediator through that is inflammation. Now,
sorry, can we just go back to that? This inflammation thing. Just explain why are we getting inflammation?
Why?
Yeah.
So to answer that question, you have to understand a little bit about what the immune system is, and accepting that some of your listeners may not be doctors, I'll just very super briefly explain it. Right?
Yeah.
So you can think about your immune system existing in two
God
states.
He said that.
Well, it's James. We have to pretend to be stupid just for the pretense of the interview.
You know damn well what I'm talking about.
Yeah.
So you've got an innate immune system, which is like a pre-programmed defense system that will attack anything that comes into your body, no matter what it is, and it's made of cells that you're born with that are primed, and it has no memory, and it's just a first line of defense sort of killing system. Then you've got an adaptive immune system, which has a memory, and it has to be told who is friend and who is foe. And it's sort of like a targeted, attack.
Like an SAS strike team.
Well, it's interesting you say that. Like, a lot of the language of immunology is based on like Cold War defense language, because a lot of it was discovered during that time. But actually, if you go back to Mechnikov's early work, who's like the founder of modern immunology, like he discovered phagocytosis in macrophages and things like that. He actually described it as a memory. Like, your immune system isn't really a defense system. It's a molecular memory of everything and everyone that you meet in your world all of the time.
It's like a catalogue.
Yeah. And your gut will have to deal with, more antigens in one day than the rest of your immune system will deal with in your entire life. And so, lo and behold, a large part of your immune system is located in your gut. So 25% of all T cells are in your gut. And there's a big old collection of immune cells that are there. And so your bugs teach your innate immune system, and they teach your adaptive immune system who's bad, who's good, and in fact, actually, mums will pass down some of those molecular memories through breast milk and through a kind of whole complex cascade of ways.
And how does it do? Sorry, I interrupt you there. So how does that signalling happen that the bugs are like presenting these antigens, these kind of molecular signals, but how can they present them as friend versus foe? How does that bit work? How does the body know what's good bug, bad bug, pathogen, friendly?
So that's because, it's a really good question. But so the answer to that is because we have co-evolved with these microbes to have a set of shared processes which we rely on for them to trigger and to maintain for us. And the difference would be, for example, also in the biology of the bug, right? So pathogens have a set of genes that are designed to be very, very aggressive and to ensure the success of that bug at the cost of absolutely everything else. Like, if you get Ebola going to kill you, and there's not very much you can do about it because it's a super, super aggressive pathogen, right? Yeah. And that's actually a fundamental thing about what we're talking about here. We're really talking about pathogens, things that cause harm, because they have got the cellular warfare instruments at their disposal to do damage, and symbionts, which don't. Actually, they're kind of interested in a bit of peace and hanging out and just gleaning from your diet what you can give you.
Some of them are turning up with machetes and Kalashnikovs, and the other things are bringing flowers.
Others like, hey, you got any chips? Right. And so what happens is that when you're born, actually what happens is most babies will be breastfed, not all will be, and you get these huge super blooms of bifidobacteria, and these bifids then start to switch on cellular functions, and the immune system, it kind of knows they're coming, and it's kind of all right.
Oh, hey guys.
Yeah, right, Lance. Hey. Right, in you come. Whereas if a baby, has a nasty strain of E. coli that's a pathogen, it's going to get sick. And that's the difference. Yeah. And the language through which bugs communicate with the immune system is quite sophisticated, and there are multiple different types of languages, and there's not just one language that they speak. So they speak through a cascade of small molecules like metabolites. They might make proteins that do that communication for them, or there might be some sort of direct invasion of cells. So we find bugs in lots of places that we didn't think we would.
Right. So going back to the inflammation point.
Yeah.
So how does the dysfunction at this barrier between us and the bugs, how does that result in inflammation?
Okay. So you brought up the word barrier, and I'm going to just jump on that as a kind of one way to explain that. So there has been an increasing appreciation that natural barriers that we have in our body, where a lot of these bugs coalesce and live, and where a lot of our immune systems are based, are quite important in maintaining our immunological health, right? And we've got them in the gut, we've got them in the lung, we've got them throughout the body. And the gut barrier is quite important. You might have heard of this phrase called leaky gut syndrome. Yeah. It's a phrase I don't like very much. I try not to using it. But anyway, there is a theory that if that barrier is damaged, and it's damaged by ultra-processed foods or environmental contaminants or antibiotics, and that barrier breaks down, that the immune system becomes upregulated because of that damage, and then that has a systemic consequence as a result of that. All right, so you have to think of barriers I think of them a bit like a Great Barrier Reef. Right, a barrier where you get that natural border between land and sea. You get like this multitude of life forms, and actually the coral reef has its own life force, its own microscopic life forms that maintain it, and obviously all the other systems around it. And it's inherent in protecting the health of the land. It stops storms breaking onto the land and causing damage, but also protecting marine life, etc., and oceanic health. Right, and your gut is just the same. When the lining of your gut fails, it's the same as losing a barrier reef. It causes the same systems damage that you would see when, in fact, sadly, as our barrier reefs are being bleached and we're losing them. It's exactly the same principle.
Right.
And then basically with inflammation, if your immune system is on overdrive, that's when we can get systemic disease, when the immune system can start to attack normal healthy bits of you, your joints, your heart,
exactly
your,
right.
your bowel.
100%.
Yeah.
So of course, you've got immune cells in all of your body. You've got an immune system absolutely everywhere. And that's also in communication. So the immune system has soluble messengers that cascade out and communicate and upregulate it. Yeah.
James, in your book, you've got chapter 8 is how to live to 100.
Yeah.
Ultimate clickbait.
Yes.
Right.
Don't smoke.
Yeah. And you talk about these 4 healthy rules for life.
Yeah.
Can you just elaborate on what they are for us?
Yeah, that's pretty good. So number one.
I'm going to see if you've read this book.
Okay, fine. I say this to all my fellows when we're operating.
Yeah.
It's like the 4 things you've got to do. So number 1, don't smoke. Number 2, don't be morbidly obese.
Yeah.
Number 3, live in a country with a developed healthcare system that's affordable, right? And number 4, don't ride a motorbike.
Okay.
All right.
And if you don't do those, then you can live to 100.
Yeah, I like riding a motorbike is so fun. If you've never done it, if you've ever done it, I love riding a motorbike. It's brilliant. And
I've never done it.
And smoking's great. And I love to eat
orthopedic
nice.
surgeons, we don't tend to favour motorcycles, do we, Pete?
No.
It's virtually every medical legal report you've ever done involves a motorcycle.
Exactly.
It's the trauma call, isn't it?
Yeah.
That's why I stopped riding a bike in the city, actually. It was the double trauma spike morning and evening.
Yeah, donor cyclists.
Yeah, exactly right.
Right, yeah.
But the point, I suppose the point I'm trying to make with that is that actually those things sound like choices. Like it sounds like you've got a choice not to smoke, you've got a choice not to be obese, you've got a choice. But actually some of these things aren't choices.
Yeah.
And the point that I'm trying to make is that obesity is a really good example of that. Like I think, we've got this really catastrophic global obesity pandemic, which just locks children and young people into a lifetime of suffering. And that's not their choice. They do not choose it.
That's socioeconomic.
It is socioeconomic and it is multifactorial, of course it is, but it's also biology. And one of the things that we're trying to say here is that actually a microbiome might be an important part of that story. It's not everything, it's part of the story. And the reason for that is inflammation. And it's the same reason why we used to give antibiotics to chickens to make them fat. Like you trash the microbiome, these animals get, get an inflamed gut. You feed them lots of fat. Lo and behold, right, you end up with a type 2 diabetic, morbidly obese cow.
But it is interesting what you're saying about the
Delicious.
Cow.
Wagyu.
Yeah.
No, but it's interesting what you said about the socioeconomic, because the fact is, I don't know, a salmon might cost £5 to buy, right? Whereas you can get chicken and chips from Whitechapel Fried Chicken for $1.99.
Yeah.
Apparently, allegedly.
So actually, I think we should, Chris Van Tulleken's just written a book on this, isn't he?
What's that, Chris? And he's left me on red for about 6 months.
Man, I would never do that.
Yeah,
I would never do that to you.
No,
this is why I'm here.
Yeah.
But like ultra processed foods, you should think about them like smoking. Yeah. They are as bad for you as smoking. It's just that we don't conceptualize them, and also the tax, incentivization is not there, and we don't have effective healthcare policy that kind of prioritizes these things. And in fact, this book isn't really a book about biology. It's actually a healthcare policy book that says you can begin to you can use the microbiome to understand why these socioeconomic factors cause disease, and you can then use that to make healthcare policy that's fairer. Like mental health is like another good example of that. Like 16 to 17% of the population take an antidepressant.
Yeah.
That's mad. Like, how the hell did that happen? Young people are suffering from this terrible burden of depression and anxiety. And some of that is because they're addicted to TikTok and because, they don't, they're living in isolation, or they're not having the social, development that they need early in life, or they're exposed to trauma or alcoholism, all these other social factors that we know. But some of it is because their biology is not being primed right. And we've got really good experimental systems through which we can demonstrate that. And again, unless you begin to go back to early life and say, look, we're really going to prioritize the health of the holobiont. Here's another word for you. Holobiont.
Okay.
Right, holobiont.
Everyone knows what holobiont is.
Yeah, come on, Pete.
Sounds like a rock star.
What is this?
She's a nightmare.
So
Such a diva.
Like, unless you say, look, we're going to not just optimize the health of that individual, but we're going to understand that the individual's health is dependent on their ecology, right? They're microbes that live with them. And actually you've got to think about that holistically. You're not going to be able to solve some of these fundamental problems.
Do you want to define holobiont for us?
So holobiont is an evolutionary term that refers to usually a mammal, so a human, and all of the microbes that exist within it, okay, that maintain its health and influence its evolution. So just to deviate for a little bit, like there's this sort of obvious, well accepted, and I'm not going to deviate from this because the internet will absolutely murder me, but like there's a Darwinian theory of evolution, right? This is theory of the...
As long as you don't say exposome, we'll be fine.
Yes, I was going to say that. But like, there's survival of the fittest, right? I think most people understand that. And then there was this woman called Lynn Margulis, right, who was this evolutionary biologist, and she was this awesome radical, this fantastic woman. Anyway, she came up with this idea that actually symbiosis is as an important evolutionary force as survival of the fittest. And this was hugely controversial in all the evolutionary...
Two organisms living in harmony.
Yeah. Well,
or teaming up.
Yeah. So there's a big bun fight about it. But basically, she came up with the idea that maybe a mitochondrion, so this like cellular energy life force that we all have inside us, actually was an archaeon, so an ancient bacterial ancestor that got endocytosed into another cell.
Got gobbled up.
It got gobbled up, right?
Yeah.
And that was an evolutionary
and it
step.
just stayed with us.
That was important. That stayed with us. So she came up with this word holobiont to explain that actually we're not evolving in isolation. We're evolving with our microbes, and sometimes we hit an evolutionary fork in the road and they skip along with us. Sometimes they might force us down a particular track. Sometimes we lose a few on the way. And that's what a holobiont is.
What can we do to optimize our microbiome for optimal health?
Yeah, so I'm listening to this thing. Right, okay. Well, I've got to get this right. How do I? What do you find yourself doing to optimize your holo?
Please don't say it's kefir and sauerkraut and ming like that.
I love kefir. Do you not like kefir?
I've never.
Oh, dude, it's
I think
great.
I've tried it once.
I love it.
Yeah.
Bit of sauerkraut.
I could eat sauerkraut.
I could eat for breakfast.
Okay.
So look, nutrition and diet is really, really important. So I'm gonna give you two answers to that question. The first answer is kind of depressing, and then the second answer is going to be lots of useful information that you can meaningfully use. So if you don't want to listen to the first bit, don't listen to the first. So the really big takeaway here is we are experiencing an internal climate crisis. That's what's happening here. This isn't about the loss of one bog. A bit of kimchi ain't going to make this all better, right? This is not the message here. The message is that if you want to really fix this problem, we collectively as a society need to acknowledge that it's a problem and then create healthcare policy that optimizes the microbiome, and we all need to collectively do things together to make it better. And that means having collective responsibility about how we prescribe antibiotics and when we prescribe antibiotics and how we use them in our farming and how we think about vaccination programs and how we communicate them and how we fund science to understand what the microbiome is, right?
And also just as equally public patient education.
Hence this podcast. Hence the good and fine work that you gentlemen do.
We're not doing it to make money.
Yeah, exactly right. I mean, you're not paying me.
I bought the damn book.
Yeah, 10%. 10%. So yeah, first answer that. And that's what I think. And the second answer to that is
then we're doomed because we can't rely on policymakers to sort that out.
No, I think some of our policymakers don't have good microbiomes.
Yeah.
maybe that's the excuse we'll give them. So look, the good news is that actually there's lots of things that you can do. And we've done lots of science to prove that there are lots of good things that you can do. And some of them are really obvious and some of them are less obvious. So number one, diet. All right. Obviously it has to be diet because what you put into your system is very, very important. So that means, again, if you do one thing, a high fiber diet. So if you can have 7 more grams of fiber per day, your risk of cardiovascular disease goes down, your risk of cancer goes down, your risk of metabolic diseases goes down, everything gets better. And part of the reason fiber works is because of microbes, right? Because bugs break all that lovely fiber down into metabolites that are anti-inflammatory.
And there is kind of a fiber... A lot of people aren't getting the fiber they need, more than you realize.
No one in this country, no one gets it. It's terrible. In fact, actually, most surgeons... Not you two.
Yeah.
Most surgeons don't even know what fiber is, and they give appalling nutritional and dietary advice to their patients.
Yeah.
So I think at medical school we got no nutritional and dietary advice. Do you remember any?
Whatsoever.
Absolutely none, right? Which is
I just
shocking.
remember Jackie Robbins.
Yeah.
But that's I don't remember anything
different
else.
reasons, Kash.
For different reasons, yeah.
She was,
There's a blast from the past.
Yeah. She was nurturing in a different way for you.
Yeah.
So yeah, diet very, very important. And so fiber very important, de-westernizing your diet. So that means also avoiding ultra processed foods, and it means it does actually mean having a little bit of fermented foods in your diet if you can regularly. That will help you.
Name some. I want to make this kind of prescriptive or
Fine.
clear for people.
Okay, good. So sourdough, kimchi. We talked about sauerkraut. We talked about kefir. And there are endless cookbooks right now.
Is there
because
anything
it's so hot. And
Is
so
there anything that does that tastes nice?
Yeah, they all taste nice.
Okay.
Soy.
Oh, lovely.
Soy.
Sourdough's delicious.
Yeah, it's absolutely delicious.
Sourdough
Really
bread.
good. Yeah, it's really good.
Does that
It's really
count?
good. Yeah,
Okay.
yeah, that does.
I'm in.
So the other really important thing you have to do is you've got to take your iPhone and go to your delivery apps and just delete them all.
Right.
And never ever take any delivery food again, ever, because it's really important for a couple of reasons. Number one is because actually you've got to get off your fat arse and do your own thing, because that keeps you active. But number two, how you cook food has a big impact on your microbiome.
Right.
If you're not controlling it, it will be important. So if you're overcooking your vegetables, or you're putting too much of the wrong oils into your food, it's going to be problematic. So you need to take ownership and you need to cook it. But also you've got to share bugs, man. You've got to be social. So one of the biggest problems of hyperglobalisation is that we're isolated. We're living alone and we're not sharing. And actually, when you're living in a community of other people, like we used to do, you share bugs the whole time, and that stops. So socialising isn't just important for your mental health and lots of other aspects of your health. Actually, from a microbiome perspective, it's important.
And there's more and more social isolation now. So there's...
Yeah, like family size is decreasing, right?
Yeah.
So I think in Germany, the average family size is something ridiculous, like, is it 2.9 or 1.9? You have to Google it.
It'd be less. It'd be the lower one, yeah.
Yeah.
No, and on a completely separate side, I think the impending population demographic crisis is going to be overwhelming, and no one's talking about that. But I think we might have come back for another podcast.
We can definitely talk about fertility because, look.
Don't look at me.
We haven't even talked about the vaginal microbiome and vaginal transplantations and vaginal microbiome transplantations and all that jazz. It's so important for gender and sex specific health and for fertility and for sexual health and these things, like really, really important. And they're only slowly now being talked about, as they really deserve to be talked about. And actually, you asked about what we can do about the microbiome. Like sex is, it's one of those things, isn't it? That when we think about sex and we think about sex lives, we think about sexually transmitted diseases, don't we, Kash?
We do a lot.
And actually, you think about the microbes that might do you harm, but actually, that's an important way through which we share symbionts through our social networks, and they're really important. So social connection, both physical and mental, very, very important for your microbiome.
So if you're saying it's passed on through sex and a lot of it's in the bowel, are you advocating anal sex?
I'm a colorectal surgeon, and I advocate that you should do what makes you happy, as long as you're having safe sex.
I'm going to cut that.
Safe sex is absolutely fine. It's fine. Yeah, lube.
I had a great question that you just kind of blown it out of my head.
It's fine.
What is it inside ultra processed food that makes it bad?
Okay.
Is it just high sugar, high fat?
It's not. So ultra processed foods there's an official WHO definition, and there's like 4, maybe 5 different categories of them. Some of these ultra processed foods are foods that are just the constituents of food that we basically make out through industrial processes and given very high volumes. Some of them are food extracts, and some of them are supplements that we put in food so that we make food last longer, taste better, or so emulsifying agents would be a really good example like that. Some of them are additives and colorings, and I think ultra processed foods have been, rightly slagged off for causing lots of harm. But you have to remember they're cheap and they're affordable, and they make eating, if you're living in a cost of living food crisis, doable, right? So I don't want people to. It's not the people that are eating the food that are the problem. It's the companies and the governments that are allowing it to happen.
Yes,
that's the problem, right? So it's just that problem. So the interesting thing about that is that trying to understand how individual components of ultra-processed food cause harm through the microbiome is quite tricky, because you alluded in your introduction that all of these things work in networks, right?
Yeah.
So if you take a form of gum like xanthase gum, when you have that, which would be an example of an ultra processed food, what happens is it gets bugs attached to it. They grow, they make a metabolite, and that little metabolite will go downstream and cause a bloom of a second bacteria, and it's that causes the harm and causes the inflammation.
Right.
But it might also directly damage the gut barrier. We talked about that Great Barrier Reef in the gut, didn't we? It does the same thing. It causes harm.
Gently poison that in a subtle kind of way.
Yeah. So it changes the ecology of the gut. It damages the gut directly, and these two things then will basically take the brake off the immune system or fire it all up, and then you end up with damage over a period of 20 or 30 years.
Yeah.
Don't eat, ice cream. Sorry, kids. Add that to one of those 4 things.
For xanthase gum, yeah.
Yeah.
And can I ask you, one thing that you've become quite associated with now are fecal matter transplants.
Oh, yeah.
Which is taking shit from someone and implanting it into somebody else.
Yeah.
And I appreciate
You want one?
No, not right now.
I can help you.
Tell us about them.
Okay, so fecal transplantation now is standard practice in the NHS for Clostridium difficile infection. We have nice guidance, and if you get sick and you're unlucky enough to get that, you can get one on the NHS. And fecal transplantation has been around for many thousands of years. I think the earliest dates go back to the Chinese when they gave it as yellow soup for people with traveller's diarrhea.
Oh.
So like we've known for a while that it's been important. And in fact, if you go through the animal kingdom, lots of animals are, they consume feces because it's part of their kind of normal health, right? Yeah. So panda bears give their babies feces as soon as they're born so that they can metabolize bamboo, because it's bacteria that metabolizes bamboo for them.
So it's not that you're taking it out the bum and putting it up someone else's bum.
Well, I would.
How'd you give it?
Could absolutely rely on you to describe it that way. So, so fecal transplantation. So there's two quick things to say about it. The first is that it has been an experimental vehicle for understanding what the microbiome is and how it works for a really, really long time, right? And we've done that for many decades. In fact, if you go, Louis Pasteur actually was talking about it. If you go back to his early work, and the second thing to say is that there are hundreds and thousands of FMT trials going on at the moment on everything from orthopedic conditions like rheumatoid arthritis and osteoarthritis and inflammatory conditions of the bones and joints, through to cancer therapy and mental health, allergy, but also addiction and a whole bunch of other things. And that's because, the microbiome is a kind of important player in it. How do you give it? Well, it's pretty gross, but there are two ways of doing it. But you take a donor and you screen that donor in the same way you would screen any donor for any other transplant. So they've got to fit a certain criteria. They've got to be healthy, and they've got to have a specific diet. And then you sample them, so you shit in a pot, pretty much. And then we sequence out and we culture that to make sure there's no microbes that are pathogenic in there. So we take out all the pathogens, screen any viruses. Now, if you're doing it in the simplest way, you then mix that with a bit of saline and you basically turn it to a milkshake, stick it in a bag, and it either goes down a nasogastric tube, so a tube in the nose into the stomach, or it can go via enema or colonoscopy via the bottom.
So you can squirt it up.
You can squirt it up.
Right.
And now
fire in the hole.
Yeah, fire in the hole. Stand back. Stand back. But increasingly it's being turned into an industrial product. So what you're now starting to see is microbiome targeted therapeutics, where they are industrializing these processes, working out specifically which communities have the health benefit and how they work. And you can now have a capsule. So a capsule is like lyophilized, or freeze-dried bacteria that come in a dissolvable capsule, and you just eat the capsule.
And so why are we not? So if I had a nasty throat infection or something, and I had a course of antibiotics, would I be well advised to go and seek out one of these capsules after I've had that? So
you'll be better advised to think about your microbiome before you take the antibiotic, and you make it as resilient as you can. And it's really interesting actually you bring up this antibiotic thing. So there's this theory at the moment of antibiotic scarring. There are some people that are very, very susceptible to even a single dose of antibiotic. And there was quite a famous study that was published in Cell a couple of years ago. I can send you the link if your listeners are interested, where they gave a single dose for quite a broad spectrum antibiotics to healthy volunteers. And a percentage of these participants developed the microbiome of someone who's just come out of ITU after 6 weeks, right? Everything in their gut died. And after 2 years, it just did not grow back.
Wow.
Right. So a single shot of antibiotics, some people can be really quite catastrophic. But no, you shouldn't be having an FMT for a single antibiotic use. And you should only be having an FMT within the context of a clinical trial, because there are lots of unintended consequences and unknowns of FMT. Because actually it's quite a blunt instrument, because we don't really know. And we started this conversation by talking about dark matter, right? It's brown matter really, isn't it? But we don't really know actually what the therapeutic component of an FMT necessarily is. We've got some theories about what it might be, but we don't know for sure. And we might be, if we hypothesize that maybe some people have an oncogenic microbiome, for example, be inadvertently putting people onto a course of cancer down the line 20 or 30 years, we just don't know.
Right.
And there are also kind of weird and wonderful side effects. So there's lots of stories of lean people having an FMT and they become obese suddenly.
Yeah.
Or Bald men. There's 2 case studies reported, at least 2 there were.
We're looking nasty.
I don't know why.
Sprouting hair.
Yeah, literally.
No
There's
way.
people with alopecia, I think it was alopecia totalis, don't
Yeah.
quote me on that, and the hair just suddenly grew back.
Hook a brother up.
Yeah. so I have a great hope in FMT, and there are people with a modern urbanized gut who have, bloating dependent IBS, or they have severe abdominal problems, who actually may benefit from an IFMT.
Yeah.
And there is a theory that maybe if you go, on a trip to somewhere where you're quite likely to get a bit of, post-infective IBS, to actually buy a bank before you go, and then we give it to you when you get back.
Right.
It's actually not that bad an idea.
Buy back your own stool.
Yeah.
And then when you come back.
So if you're going in to have surgery, you're going to hospital to have your knee done, your hip done, you buy back your stool, you go in, take all the antibiotics you need to get you through the surgery. We'll trash it. Doesn't matter. When you come out, we'll just give you a lovely FMT and you'll be all better.
Right.
Yeah.
It's fascinating, isn't it?
Yeah.
That's amazing.
Yeah.
Yeah.
I don't think that will happen.
But you should be. But the key is to be nurturing, taking your microbiome seriously in advance of surgery, so that you're
For sure.
at all these things. So it's as you said,
Yeah.
diverse and resilient.
So
Taking care of it.
But it's also like for your clinician listeners, right, to take it seriously. So when they're talking to their patients, like these things really do matter. What you eat really, really does matter for that reason. And in colorectal surgery, I'm a colorectal surgeon. Like there's been this kind of revolution as we've slowly had the scales of surgical dogma fall from our eyes, and we've realised that maybe biology is important in how we form anastomosis. So like when you join 2 bits of bowel together.
Yeah.
Right. There's this old.
Don't you use a stapler?
Yeah. Well, yeah. Now I do. Yeah.
Yeah.
This old surgical dogma: no tension, good blood supply. Perfect surgical technique. Actually, it's microbes in the anastomosis chomping on collagen. And if you've got a westernized diet and you're morbidly obese and you're diabetic and you smoke, all of these things we know increase your anastomotic leak rate. Right. Lo and behold, you've got more of these collagenase producing microbes in your anastomosis, and it's likely to leak. And in fact, you can transfer a leak phenotype from a human. So if you take feces from a human that's had surgery and leaked, and you put it in a mouse and you join its bowel together, the bowel will fail.
Well, also,
right.
Yeah.
So leak is a transferable phenotype, right?
Yeah.
So like surgery's got a lot of catching up to do. We're a long way behind.
What's the strangest thing you've learnt about the microbiome?
The strangest thing that I have learnt is that is its importance in brain development. That's the thing that just really I just find quite extraordinary. So this idea that children who have conditions associated with neurodiversity, the most controversial of these is autism spectrum conditions, might be caused by perturbations in the microbiome, or microbiome isn't properly formed in early life. And the thing that
disturbances.
Yeah, disturbances.
What's a perturbation?
Perturbation is I suppose a disruption in the function of those microbes.
Right. A disturbance to me.
Good word.
Yeah.
You should use that a bit more.
Note it down, darling.
Yeah.
So there is some very interesting studies where they took feces from autistic kids and they transferred it into mice, and those mice developed autistic behaviours. And then if you take the feces from a child, a twin who does not have autism, and you then put it into the same mouse, they will go away. Not all of their behaviours change. It's subtle and it's nuanced. But what's quite interesting about this is that when you start to do these things after weaning, those change, you lose that effect, which means that there's a short window. There's a short window where actually you've really got to optimize the microbiome potentially for brain development. Now, again, like autism's just like it's a very difficult thing to sometimes have a discussion about, but actually it's important that we do talk about these things and acknowledge that actually it's a complex mechanism, and there might be things that are associated with its causation that are non-mammalian, like microbes might be really important.
Yeah. Do you have a favourite bug?
Akkermansia muciniphila, good bug.
What do you like about him?
I like the fact that I like the fact that it's kind of universal. It pops up in a lot of different microbiome studies, and it's really important in maintaining the gut barrier. And I like saying it.
What does it look like?
It looks hot. It looks real sexy. It's as sexy as you.
Has it got little fronds coming out of it?
Yeah.
Okay, let's just stop this here. I'm quite perturbed by this conversation. Listen, James, thank you very much for coming in.
Hey, my pleasure.
Plenty of food for thought. It is. I've never plugged a book before,
but here it is.
And he didn't know we were doing this. It's Dark Matter: The New Science of the Microbiome.
10% Kash.
10%. I'm on commission here.
Yeah.
And do check it out. It's a fascinating book.
Yeah.
I've also listened to it on Audible, and it is well worth listening to as well. And James, look, if we get lots of questions, we might bring you back in.
100%. I'd love to come back. It's been a real treat talking to you.
Flip you over and play the B-side.
It's only taken us 20 years to see each other after medical.
Yeah.
We'll do it again.
I'll see you at retirement. Cheers, buddy.
Cheers.
Thank you
so much.
James.
Cheers.
Thank you.
Thank you.